Hey, good night. We're going to talk about today scientific notation. What is it for and how do I do it? Here's the gist, really. Scientific notation is for units that are really big or really small. Really big, like space, planets, or really small, like atoms and nuclear stuff. I wanted to look up some space units real quick, so I went to a website called Data Genetics and got a few. The first thing I looked at was the sun's diameter. Bigger than the Earth, obviously, but in terms of the whole solar system, still kind of small. The sun's diameter, I found out, was a measly 1,391,100,000 kilometers. The next thing I looked at was the Earth's average radius to the sun, or the distance from the sun to the Earth as we go around. Got a little bigger. It was 149 million on average kilometers. Still not that big a deal, 9 digits I guess, but if you don't want to write a lot, we're starting to get there. The next thing I looked at was Neptune's radius, now the furthest planet from the sun. Neptune's radius was, can you read it? 4,500,000,000 kilometers. Now we're starting to get into numbers that, if you're showing all your work or you're even typing all this stuff, it's way more than you want to start to type. So that's why we use scientific notation to make, well, especially they needed it for calculators, but to make our work look a little cleaner and to write a lot fast. Here's our scientific notation rules. I want you to pause that and write those down. First digit should be an integer. The number before the decimal should be a number between 0 and 9. And every number to the left or the right of the decimal represents a positive or a negative exponent. Remember how negative exponents usually make for those fractions? That's why a negative exponent is a super small number, because the more of a higher exponent we have there, the more of a negative, the more of a larger denominator we would have. Let's go back to Neptune though and just look at how to convert that. It said that the first rule said that we need to have an integer between 0 and 9. Let's just write our number down here again. Oop, too many commas. Alright, 4,500,000,000. We need to start with our 4. Can't be 45 because that would not be between 1 and 9. Next order of business is you have to write, I think Ms. Dombrink would call it significant digits. So you write all those numbers that are numbers not 0 that would come after the 4. So we write a 5 there. The last thing you have to do is just count to the end. And my decimal point is here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And that tells me my exponent. 4.5 times 10 to the 9th would be Neptune's radius in scientific notation. So that's it, really. Let's go backwards real quick, I guess. If I was going to look at 2 times 10 to the 3rd, go the other way with it, that would mean I'd have a 2, and then 1, 2, 3 zeros behind it. That's scientific notation. Hit me up if you have any questions.